So we have already seen how the breadth first search algorithm works. Now we are going to cover one interesting application of BFS, which is finding the shortest path or the single source shortest path in an unweighted graph, right? So in an unweighted graph, you do not have edge weights explicitly assigned to all edges. Every edge has a same length, right? So what does this thing mean? Single source shortest path. In short, it is also written like this, SSSP, right? So it means starting from a one source node, a single source node, we are going to compute shortest paths to all other nodes, right? So let's see how this algorithm works. So this is nothing but the BFS only, right? So I know if I want to compute the shortest paths from this node, so what I'm going to do, I'm going to use a queue, and instead of maintaining a visited array, I'm going to maintain the distances. So initially distances of all the nodes are infinity, are set to infinity, right? And the distance of starting node is made 0 because its distance will be 0 from itself, right? So I push the first node into the queue, and then I pop out this node, I print it, and I find out the neighbors of 0 which are not visited. So the neighbors are 1 and 4. So I know, so these are the children of 0. So distance of 1 will be 1 and distance of 4 will be also 1, because it will be nothing but distance of 0 plus 1. So distance of parent plus 1. So I push these nodes into the queue. For the next time, this was my 0th level, this was my first level. In the next iteration, I am going to pop one node which is 1, and I try to visit all the nodes which are not visited from 1. So I can visit 2, and I can write distance of 2 is now 2 because the parent node is 1 and it is having a distance of 1. I push this node into the queue, right? And next time I again pop out one node which is now 4. So 4 is having a distance 1 and it will try to explore this node 3. So this node is having now distance. I will update the distance. This distance will be 2, and I will push it into the queue. Next time I can pop out this node 2, since no other nodes have been unexplored from 2, so I will not explore any other node. Finally I will pop out 3 and I will push 5. So 5 is being explored by this node 3, so 5 will be at a distance 3, because what I write, distance of child node is nothing but distance of parent node plus 1. This is the very simple logic, a pretty obvious one. So I update the distance of 5 and I push 5 into the queue, and I pop out 3, and finally I pop out 5. So you can see BFS is traversing the graph in a level by level fashion. So this was my 0th level, this was my first level, this was my second level, and this was my third level. So that's why this thing is called level order traversal. And since every node has been assigned a distance when it is explored for the first time, so this distance will always be the minimum distance. You can see for reaching 3 there could be multiple paths. One path was also going via this route, but this path is definitely longer than what is being given by breadth first search. So you can see, if another way of thinking of this is, suppose you are burning some fire at this point 0, so fire will spread like this. So it will move in this direction, it will move it along this direction. In the next stage, fire will reach 2 and it will also reach 3. It can also reach 2 from this route also. So it is reaching 2 at the same time, right? So these nodes are at the second level, and in the third stage, fire will spread like this and it will reach 5 like this. So since node 3 has been already explored for the first time via 4, so the shortest distance for this node is 2, right? So I check if a node has been assigned a distance or not. If not, it is explored for the first time, I assign it a distance. If yes, then we skip it. We do not consider that node for further updation, right? So now let's see in the code. In the code, we will require one distance array or a distance map to store, right? So we will maintain one distance map, and if we are maintaining distance, we do not need to maintain the visited thing, and we need one queue, right? And one more thing which I will take is parent. I will also store parent of a particular node, so that if I want to compute the shortest path, I will use my parent array, right? So let's see in the code. So this was the BFS algorithm we had done. So instead of taking a map, I'm taking a map of t and naming it as distance, and in the starting, distance of source node is going to be 0, and for all other nodes it is going to be int max. So I can just iterate over all my nodes in the map. So I can say for auto I belonging to my adjacency list, distance of I dot first equals to int max. So all the distances are infinity in the beginning. Now when we are popping one node, so what I'm going to do, I'm going to just update the distance. So I can say distance of the current node, which is the neighbor, will be distance of parent node, which is the node plus 1, right? And I can make also one more array, which is the parent. So I can say map of t and comma t parent. So parent of source equals to, let's say, source itself. Parents of source is source, and the discovered node, parent of neighbor, is now node. So I am using my BFS, and I'm just updating the distance when I am coming to one node, and I'm also updating the parent of that node. So after the while loop is over, I can print the distances to all the nodes. I can say for int I equals to 0, I less than, or you can say for auto I belonging to your adjacency list, your current node will be I dot first, and you can say cout distance distance of this node from source is distance of node, right? This will give me the distances of all nodes, right? This will just give me the distances to all nodes. In BFS algorithm, I have added some stuff. Now let's try to run the BFS again. We have one error. Okay, so visited we do not have, so we have to check if distance of neighbor equals int max. It means we are coming to that node for the first time, and if we are coming for the first time, we will update the distance as well as the parent of that node. So let's try to run our code. So you can see distance of 0 from 0 is 0, 1, distance of 1 is 1, 2 is 2, 3 is 2, distance of node 4 is also 1, and distance of 5 is 3. So which is same as this graph. So fourth node is at distance 1, fifth node is at distance 3. So you can see, using the simple BFS algorithm, we have computed shortest paths for a unweighted graph. So you can look at the code, And thank you for watching. I will see you in the next video.